Hello Potato! Welcome to the second installment of my Pixel Fire Geometry Nodes tutorial series. In this video, we're going to be creating a system that affects our instances based on the proximity of another object. Let's jump right in. For this tutorial, we're going to use the point grid node group that we created in the previous tutorial. If you haven't checked it out yet, here's a quick summary of what we did. Pretty simple, right? So, to make the point grid node group a part of our newly created scene, all we need to do is append it. Go to File and click on Append. Navigate toward where you saved the point grid project from the previous tutorial. Double-click on the Blender file and go to Node Tree. There, you will see your point grid node group waiting for us to plunk into our scene. Drag a new window and set it to Geometry Nodes. Select the default cube and click on the New button on the Geometry Nodes window. As before, Ctrl right-click drag over the geometry connection to get rid of the cube geometry. Now, to add our point grid node group to use for our pleasure, use Shift A and navigate down to Group and choose our point grid node group. Here's the cool part. When you connect empty sockets from the group input node into the input sockets of the node group, they rename themselves to what the input sockets are named of the node group. Brilliant! Add an instance on points node. Plug the output of the point grid into the points socket and the geometry output of the group input node into the instances socket. Next, plug the instance's output of the instance on points node into the geometry input socket of the group output node. Now comes the fun part, brainstorming. What we want to do is to use the distance from each of our cube instances to the point of, say, an empty, and take that value and map it to a range of 0 to 1. So, if the empty is further than a specific distance, it outputs 0, and if it is closer than a specific distance, it outputs 1. And in between those two distances, it outputs a value between 0 and 1. We will then multiply that value with the amount that we want to transform our instances. First, let's add a position node. This outputs the position coordinates of each individual instance. Next, add an object info node that will give us the location of our empty object. For the object info node to work, we will also need an empty object, so add that in the 3D viewport. Use the eyedropper from the object info node to select the empty object. Now, to get the distance between our instance and empty objects, we just add a vector math node and set the type to distance. Plug the position node into the top slot and the location output of the object info into the bottom slot. Awesome! Now we have the distance between the instance and empty. Now to map the distance between 0 and 1, we add a map range node. Plug the distance math node into the value input socket. We will be using the from min input as our closest distance, where the output will be a value of 1, and the from max input as our furthest point, where the output will be 0. Since we want the closest value to output 1, we will be changing the min value to 1 and the to max value to 0. The last node that we need to make the instances obey the distance will be a vector math node set to multiply. Plug the map range node into the vector math node and plug the vector math node into the scale socket of the instance on points node. Set the values of the vector math node to 1 and set the z value to 0.1 to flatten our cubes. If you don't see any of the cubes in the 3D viewport, you can always adjust the from min and from max values in the map range node until you start to see results. Increase the count on your X and Y axis. Grab your empty and move it around. For the final step, we are going to use the distance value to influence our material color. To do that, we are going to use two more geometry nodes. For the first node, we want to grab the value of our distance and store that in a container called an attribute that we can use in the shader editor. We also want each instance to store their own value of the distance. For that, we want to get a capture attribute node and plug that in between the instance on points node and the group output node. Make sure the data type is float and the domain is set to instance. Next, plug the map range node into the value input of the capture attribute node. This will store the float value of our distance into the container of each of our instances. Plug the attribute output into an empty socket of the group output node. In the Group tab, under Outputs, rename the attribute to something understandable. I'm going to call mine Distance Attribute. Now, if we check the Node Group modifier, we will see in the Output Attributes tab, our Distance attribute is empty. We will give our container with a distance float in it an identifier name to easily call on the container within the shader editor. I'm going to call my identifier distance_attribute. Now that we have stored our value into a container that is unique to each individual instance, we need to change each of our instances into their own unique object. Currently, every instance that we see in our 3D viewport is just a copy of an existing object. So, changing one instance to a certain color, for example, will change all of them to that same color. We want each instance to be their own unique object, so they can each have their own unique color. To do this, we just add a Realize Instances node and throw that in between the Capture attribute and the Group output node. I like to keep my nodes clean and neat, so let's group all the nodes that we just created together into a node group. Plug the Object Info node into an empty slot of the Group input node, as well as the From Min and From Max input of the Map Range and the Vector slot of the Multiply Vector Math node. You can rename your group input and output if you like. I'm just going to change the From Min and From Max to Min Distance and Max Distance. Tab out of the group and rename the group to Proximity. Change the Geometry Nodes window into the shader editor. Press Home on your keyboard to focus all your nodes into your viewport. To get the value of our distance float, we will need an attribute node. Set the type to Geometry and copy the identifier name that you gave the distance attribute from the Geometry Nodes modifier into the name field of the attribute node. We will also be using a color ramp node to determine our color. Change your colors to anything that you want, with the left side of the slider being 0 or the furthest distance from our empty, and the right side being 1 or the closest distance from our empty. Plug the factor socket from the attribute node into the factor input of the color ramp and the color output socket of the color ramp into the base color socket of your principled shader. And there you have a cool looking proximity geometry node setup. Don't forget to save this file somewhere where you can easily locate it for our next tutorial. For the purpose of this tutorial series, I will be saving it onto my desktop. In the next tutorial, we will be using this proximity node setup to create a cube fire, along with some other objects to create a low poly cube world. Press that like button if you enjoyed this tutorial, and don't be afraid to subscribe for more cool tutorial series like this in the future. Tjorts!